Good morning, and thank you so much for joining us today. My name is James Kroll from the Department of Entomology here at UW-Madison.
And I'm Dr. Allison Fleming from the Department of Forest and Wildlife Ecology here at UW-Madison.
And we'll be moderating the panel discussion today. We're thrilled to welcome you to this discussion today on land-water connections and the ecological impacts of water pollution on behalf of the Nelson Institute's Center for the Ecology and the Environment. Our discussion today is going to focus on the critical linkages between land use and water quality and their impacts on ecology and ecosystem health. The health of our rivers, lakes, and oceans is, of course, intricately linked to how we use land, and these links extend across continental scales. Many of these links run from land to water. For example, pollutants from farms and cities end up in our rivers and lakes, where they can have severe impacts on animal, plant, and microbial life. But the health of aquatic ecosystems also links back to the land through disrupted food webs, impacted fisheries, and even through the movement of key nutrients through the ecosystem, which you'll hear a little bit more about today. Thus, our own health and well-being are deeply tied to water quality and its ecological impacts. So with that in mind, we're absolutely thrilled today to be joined by a fantastic panel of experts from both fundamental researchers to sort of practitioners that think about these links and how to address them, taking a variety of approaches and working across geographic scales. Dr. Claudio Gratton is a professor in the Department of Entomology here at the University of Wisconsin-Madison, where his research focuses on landscape ecology of insects, including linkages between aquatic and terrestrial ecosystems. Dr. Jennifer Tank is the Gala Professor of Ecology of Streams and Rivers at the University of Notre Dame, and her research focuses on the influence of human activities on ecosystem function in streams and rivers. Matt Dybel is the Watershed Management Coordinator here in Dane County, where his work includes identifying watershed management strategies for supporting both food production and environmental health. And the Honorable Mitch Reynolds is the Mayor of La Crosse, Wisconsin, and is part of the Executive Committee of the Mississippi River Cities and Towns Initiative, which aims to improve the prosperity and sustainability of the Mississippi corridor. And so today, our plan is that each of our panelists will begin by giving brief introductory remarks, after which we'll open for a broader discussion and Q&A. So to the audience, please submit your questions for the panelists in the Q&A feature found along the bottom of your screen. You can also upvote questions from others that you think are particularly good or relevant or exciting. And with that, I'll invite Dr. Gratton to kick us off with some opening remarks.
All right. Thank you, James. Thank you, Allison. And let me see if I can actually get my screen sharing to happen. And I'm going to see if I can actually walk up to the podium here. I'm going to try to make things a little more interactive. Everyone's seen way too many Zoom calls these days, so I'm going to actually try to be part of the presentation here. So what I hope to do today is set the stage a little bit for some of the consequences or the understanding a little bit about the linkages between water and land. This is a bit kind of turning things on its head. We often think about the role that land has on water, and we're going to hear a lot about that from Dr. Tank's presentation, where water kind of gets pulled into these low places in the landscape. That's what forms our rivers, that's what forms our lakes. But there's a lot of actual biological activity that happens in these water bodies. There's organisms that live there, the things that I get excited about, aquatic insects, that then can actually emerge and come out.
Claudia, so sorry, we're not seeing your slides yet, so just wanted to interrupt you. Sorry about that.
You're not seeing any slides at all here?
No, we're seeing the presentation mode.
Okay, let me try this again. That would be a shame if you couldn't actually see what I was trying to.
Yeah, we know you have nice slides, so we wanted to interrupt you. Not quite.
Is this working now?
No, same.
Yeah, still the same thing.
It's still in presenter mode, Claudio, so it just needs to go into the full screen mode. I don't know how that works. Yeah.
Well, that's interesting. All right, how's that?
There you go. Yeah, great.
That's good. All right, I just clicked on the wrong button. That was me. Okay, so what I was trying to say was that water gets drawn into low places in the landscape. And that's usually what we think about when we talk about the influence of the land on water. It's things getting pulled into these low places. There's a lot of interesting biological activity that happens there. Insects live there. All kinds of organisms live in the water. But the thing that I want to kind of communicate in this particular talk is that a lot of organisms, and particularly insects, actually have a life phase that takes them out of the water and back onto the land, where they can interact with the terrestrial landscape. The animals that live there, people that live there, the plants, the soils, and so on. And so this reverse flow creates an opportunity for linkages, not just between the land and the water, but the water and the land as well. And that's kind of what I want to communicate today. And so the way I'm going to do this is to actually kind of introduce you and tell you a story about some of the work that we did in this particular place around these wonderful little organisms here. These are non-biting aquatic midges, insects in the group that we refer to as chironomids. And the larvae live in the water, in the sediment, where they feed on algae and scum and detritus. And then they come out as adults, which is what you're seeing over here, and move over land. This is a story that we kind of got into by studying this particular lake in northern Iceland called Lake Mývatn, which literally means the lake of midges. It actually means midge lake. It's a big lake. It's kind of the size of Lake Mendota here in the Madison area, and it's in this beautiful kind of Arctic, subarctic area. But one of the things that happens at this particular lake is that it's a very shallow lake. Imagine that it's only like 9 or 10 feet deep across this entire basin that you see here. A lot of light gets down to the bottom of the lake, and the midges just go crazy. There's a huge amount of insect production in this particular lake. And I just want to cycle through a few photos here that I took during some of these years when the midges were coming out. And this is actually that fog you see here on the land is actually insects that have moved over the land to mate and to do their thing as part of their life cycle. And here you can just see these pillars of insects covering the landscape. Here's some of my colleagues as we would go around and actually catch these insects. It's an amazing phenomenon. It doesn't happen like this all over the world, obviously. We went to this lake because it is really unique. And we spent a large amount of time actually trying to document why, how many insects are coming out of this and what are the consequences for the land. And we calculated over a lot of different years of work that about 100 metric tons of insects come out of the lake each year during these big outbreaks. And because my brain's kind of small and I had to put this into like real tangible terms, I'm like, a Big Mac is about 200 grams. And if you multiply this out, this is about the equivalent of 500,000 Big Macs getting created in biomass every year out of this lake, or about 4 semi-tractor fulls of Big Macs. And so imagine all these Big Macs kind of getting spread around the edges of the lake, kind of spilling out over the edges of the lake. That's what we're actually experiencing. That's what the land is experiencing every year there. And when these midges get into the landscape, the animals there can take advantage of them. Spiders go crazy, decomposers go crazy. It actually affects the land so that it can change from more of this heathland environment that you kind of see over here to a grassland. So around the lake, you actually see grasslands. Okay, so this is this crazy lake in Iceland. How does this have any bearing on other places in the landscape? Well, for those of us who live in Wisconsin and you've been up to Devil's Lake, here's an example of a midge outbreak that happens, or midge emergence that happens each year around April, right around this time. Insects come out of the water, they spread themselves over land and affect the landscapes there. So kind of foreshadowing maybe some of the presentations that are coming up next, the things that we do on the land that therefore influence the water has the capacity to really affect these organisms that live in the water, and therefore their potential connections to that terrestrial landscape. So this is a relationship that we have to keep thinking about when we think about these water-land relationships. In Wisconsin, if you do some really quick math, around 10%, almost 10% of the land area in Wisconsin is within 20 meters, about 60 feet of a body of water, whether it's a pond or a stream or the Great Lakes. So that's a lot of land in proximity to water. And it gets even bigger if you make that buffer, if you look within 30 or 200 meters. A third of the land in Wisconsin is near water in some way. And we did some calculations where if insects come out of the water and kind of deploy themselves and disperse themselves over land, what you might expect is some areas with big lakes like Lake Winnebago here, or up in the northern Wisconsin where there's a lot of lakes that kind of are small but overlap, or areas here kind of in central Wisconsin that you can see this yellow and orange. These are areas where you might expect a lot of these insects actually coming out of the land. So we can't really ignore it, is what I'm trying to say. We've done some work, and others have done work, that it's not just insects and decomposers that can take advantage of these, but we found that actually birds are more common in these areas right around the lakes and streams. The reproduction seems to be higher, and so these aquatic systems, things that are happening in the water, actually have the ability to ramify themselves all through the land. So anyway, that's the take-home message from my part today, is that insects move from water to land. So the things that we do in the water and the characteristics of the water has the capacity to kind of flow back onto the landscape. They bring nutrients with them, they bring energy with them, and they affect the plant and the predators and the consumers that are near land. And so with that, I think I can hand it off to Dr. Tank, who is going to tell us all kinds of other things and ways that we affect water.
Great. Thank you so much, Dr. Graton. That was wonderful. Dr. Smith, if you'd like to go next, follow that great talk. Perfect. That looks wonderful.
And great. Just wanted to thank you all for the invitation today, and happy Earth Day. It's a great day to talk about what we're thinking about regarding the intersection of agriculture and fresh water. So I'm going to talk today about agriculture, water quality, and the role, in good news, the role that conservation can play. So these waterways that drain agriculture, especially row crop agriculture, are really leaky systems. We've done a lot of hydrologic alteration on the landscape, which is really necessary to keep agriculture productive. That includes channelization, subsurface tile drains. This all speeds water removal from the landscape and allows for productive agriculture. But it means that excess fertilizer like nitrate, nitrogen, and soluble reactive phosphorus are also transported from the landscape to waterways adjacent to agriculture. And as Dr. Graton mentioned, water and land are very, they're very closely related. And so what we do on the landscape does influence our water quality. The highest losses of those nutrients occur after harvest during the fallow period from late fall to spring when fields are bare. And so what we've done is we've reduced the water residence time on the landscape. We've reduced the retentive capacity of these waterways, which means that we're increasing more nutrients to downstream waterways. And the classic example, and a big one, is the Mississippi River Basin. So our need is really that we can implement conservation that limits that nutrient loss, particularly during winter and spring when those losses are most prevalent. And the canary in the coal mine for all of us has been the Gulf of Mexico and the recurring low oxygen hypoxic zone, and caused by the algal blooms that occur in the Gulf of Mexico. And it's a long problem. So it's one of those challenges that's been around for a number of decades. I think we're making progress, but we've still got a long way to go. Layer on top of that, our challenge is even more difficult because our future climate's not playing fair with us. There'll be predicted about 45% increase in 100-year storm events in the decades to come. And that means that with this extreme precipitation coming at different times, combined with tile drainage that speeds water to waterways, that's just going to increase export. And I wanted to show a real world example. This is the stream we've been working on for over a decade, just about an hour south of Notre Dame. And this was a rain on snow event, crazy. One of the highest flows we've ever seen. This is gonna happen more and more often, rain on snow. So the challenge I think we're faced with is maintaining productive agriculture and drainage while preventing nutrient and sediment loss to adjacent waterways, especially during high flows. I'm going to give two examples of practices I think could help mitigate that. One is cover crops, quite popular, where you plant another crop like cereal. It's not a crop, you're just planting cover on the green cover on the ground like annual or cereal ryegrass. That green blanket in the fallow season can keep nutrients on the fields instead of letting them seep to waterways, and the magic's in the underground root systems. The challenge is, while they're gaining in popularity, I note our Indiana state statistics down there, and that's only to 2018, but we're peaking out at about 10% of croppable acres in cover crops. We've got a long way to go to blanket those fallow fields with green cover. But we do know from our research that those subsurface tile drains that drain fields with cover crops have lower nitrate nitrogen loss. So we are keeping nutrients on fields. And even when you look at the watershed at the export, at the pour point of these small watersheds, in general, although it's variable year to year, less nitrogen is coming out the bottom of agricultural watersheds when you plant cover crops at scale. But inevitably, those nutrients do leak, some leak. Even when you do your best on the landscape with cover, they leak into waterways. Can we do anything with our waterways to maximize nutrient retention? The two-stage ditch is another practice that restores mini floodplains on the sides of formerly trapezoidal agricultural ditches. And that increases the bioreactive surface area for biology to do its job, keeping that nitrogen in place. And we've quantified that tripling that bioreactive surface area can up to 24 times as much nitrate nitrogen removal via those floodplains. Those are the green caps on those bars. That's the added benefit of floodplains. So if I could just close my 5 minutes, hard to talk about, your life's passion in 5 minutes, but closing thoughts. Cover crops can buffer the impacts of increased storm frequency and intensity predicted for the Midwest by retaining soils on fields during nutrients on fields during the fallow season. If nutrients do leave fields, floodplain restoration via the two-stage ditch could enhance nutrient retention in those waterways, further improving water quality. And finally, adding the term resilience to management conversations, in addition to the conversations we've been having about improved soil health with conservation, may pave the way for adoption of conservation at scale in whole watersheds, in both the waterways and the surrounding fields. And I just really think that the issue is going to be critical. Agricultural conservation under a changing climate really has to increase resilience if we're going to reduce downstream export from agricultural lands. Thanks so much.
Wonderful. Thank you, Dr. Tank. And those two talks have given us a really great foundation of understanding some of the biology and ecology foundations, and then also how some of this work and the science and data can help translate to better management practices and policy decision making. And so for the second half of our panel today, we have two practitioners. And so first we'll pass it off to you, Mr. Dybel, if you want to start, and then we'll follow with Mayor Reynolds.
Sounds good. Thank you, Allison. Okay, good morning, everyone. So I'm Matt Dybel. I'm the Watershed Management Coordinator at Dane County Land and Water Resources Department in the Madison area in southern Wisconsin. And we have a pretty unusually large department, land conservation department. A lot of counties are getting by with a handful of staff. We have over 50 staff. We also manage the parks and a number of other areas, but so we're pretty well equipped to deal with these issues, but we still have significant challenges. So one of the challenges is really inherent in our mission, and that is that county land conservation departments support agriculture. We support agricultural production. We help farmers adopt the kinds of conservation practices that Dr. Tank was talking about. But we also have the mission of protecting the environment, the water resources, the natural environments, the natural terrestrial environments in the county. So these missions are often at odds with each other. So we try to find ways to kind of, find a happy medium, and that can be hard, but we do our best. So one of the ways that helps me think about kind of how we try to take on this challenge is to break down kind of the land to water issue that we're talking about today into a fairly simple conceptual framework. And if we think about something like phosphorus, that's a major water pollutant, we have sources of phosphorus, we have the movement of phosphorus from the land to the water, the transport, and then we have the impacts, what happens once it gets into the water. And then we can kind of layer on this area that's been recognized more recently, which is legacies. So this is kind of the lasting effects of practices and the use of the land that happened in previous decades or centuries even, that is still having effects today. And that can be on the sources of a pollutant as well as the transport. Things like channelization and tile drainage that Dr. Tank was talking about can fall into that in many cases, into the legacy. So I'm just going to give two brief examples of how we're looking at this conceptual framework in Dane County. First of all, on the source side, we've recently completed a phosphorus mass balance for the Yahara watershed here in Dane County, which really helps us understand where the phosphorus that's getting into the water is coming from originally. And then secondly, we've started developing terrain models to really understand where these low spots are that can hold water and associated pollutants, and not necessarily let it get to downstream water bodies like navigable streams and lakes. So this is a graph showing the history, the last 25 years roughly, of the phosphorus mass balance in the Lake Mendota watershed. So that's the largest lake in the Yahara chain. And what you see in the top plot there are the major sources of phosphorus, the major imports of phosphorus into the watershed, ag fertilizer, and then feed demand for dairy cattle primarily are the major ones. And then in the bottom part of the plot, the annual export of phosphorus, what's leaving the watershed. The big one is livestock products, primarily milk in this area. And so, there's some much smaller components of this mass balance that you can see in the plot, but they're really dwarfed by the big ones that I just described. The good news is that over the last 25 years, we've actually greatly reduced the net import of phosphorus into the watershed. That's the dashed line on the top plot. So we've gotten close to a net mass balance, meaning exports are getting close to imports. However, that means we're still accumulating phosphorus. Every year, more and more phosphorus is building up in the watershed. Some people talk about that as like a ticking time bomb. We're building that store that's vulnerable to leaching and running off into the water. But we're getting closer to making that balance. And how to get to zero on the top plot, which I'm not going to get into right now, but we can maybe discuss later. All right, and then the second example I want to talk about is this terrain modeling. So this is really understanding how the shape of the landscape, the terrain, and where we are here in southern Wisconsin is near the terminal moraines of the last glaciation. So there's a lot of interesting complex landforms that were created by the ends of the glaciers, a lot of depressions, topographic depressions. And this map shows our recent estimate of where those depressions are. So the red areas are areas that don't drain out to a stream or lake, that are essentially closed depressional areas. And this is a much larger area than was previously known for this area. It had been estimated previously that about 15% of this watershed was internally drained. Now we can estimate that it's closer to 40%. And that's because there's a lot of really small pockets that you can see in this map, the red areas, that cumulatively add up to a really large area. So what does this mean? Well, it means that conservation in those areas may not be as important for the lakes, for example. And so that allows us to focus our efforts on ag conservation in the areas that are not in the red areas, that have direct hydrologic connectivity to the lakes. So this is still a work in progress. If you want to find out more details, I've got a link there to it. Yeah, those are a couple of highlights that I just wanted to start with today. And I think we can turn it over to Mr. Reynolds.
Great, thank you so much, Mr. Dybel. That is really helpful and great to sort of bring us into a closer geographic range. And I'm sure we'll have many questions for how these connections exist between the science and that decision making for afterwards. And yes, Mayor Reynolds, we'd love to hear from you now. We'll pass the microphone to you.
Well, thanks so much. And it's an absolute honor to be here today. And especially thanks to Dr. Fleming for inviting me to join, not only as the mayor of the city of La Crosse, my beautiful city between the river and the bluffs right here on the western edge of Wisconsin, but also as representative of 101 mayors along the Mississippi River, as part of the Mississippi River Cities and Towns Initiative, or MRCTI. I'm the Wisconsin chair of that organization. And for those of you joining who are not aware of MRCTI, we're, again, an association of 101 mayors along the Mississippi River, all the way from Bemidji to all the way down to New Orleans. And our membership hails from all 10 Mississippi River states, and we are certainly committed to securing our freshwater resource that is also our waterway. So water quality improvement is a top priority for the mayors along the Mississippi. And so if we have clean water, then the 50 cities of basically 20 million people drinking the water can be assured of a secure source into the future. Our freshwater economy on the Mississippi comprises over $400 billion worth of annual revenue generated by the river, supporting 7 distinct economies. Manufacturing, tourism, ag, outdoor recreation, water supply all need the same thing to thrive, of course, and that's clean water. 959 million gallons of drinking water is provided by the Mississippi River daily to public water systems, including ours. And the Mississippi provides over 8 billion gallons in fresh surface water withdrawals total each day. Now, of course, we see nutrient loading and the ecological impacts of water pollution on the aquatic ecology as one of the most significant threats to our freshwater security, and consider it therefore paramount that we work with all of our states and federal agencies to reduce errant nutrients and pollutants throughout our watershed. And one way we're pursuing this is through scientifically guided deployment of natural infrastructure. Mayors from these 10 states, as well as global stakeholders, have come together to complete one of the nation's largest natural infrastructure disaster capacity studies. MRCTI has partnered with 2 Degrees Adapt, Cargill, Black & Veatch, One Architecture, and others to complete a study on where to deploy what kind of natural infrastructure assets and at what scale to achieve multiple co-benefits, including water quality improvement and disaster mitigation for some of the most vulnerable areas of the Mississippi, and all along the corridor. Of course, now once we completed the study, then we went to work on onboarding broad-scale conservation projects in the upper, the middle, and the lower river valley to activate 60,000 acres of working natural assets to absorb over 7.5 million tons of nutrients, implicating 30 cities in 8 states. Now, for this portion, MRCTI has additionally partnered with Global Conservation Authority Ducks Unlimited to design and deploy natural infrastructure projects throughout the Mississippi River Valley, using the 2 degrees adapt disaster capacity study as a guide of where to place those projects at what level of intervention for maximum return now and in the longer term. Now, here in La Crosse, we get our water from a giant sand aquifer that's located between the river and the bluffs. And of course, the state has developed several solution platforms for cities to help reduce nutrient loading, including a water quality trading regime, bank stabilization, catchments to filter runoff, and others. Here in La Crosse, 10 years ago, we developed a stormwater utility for the city to not only address the mandated reductions in stormwater going into the river, rivers. We're at the confluence of the La Crosse Black River and the Mississippi River, but also to build out that infrastructure, but to do it equitably and create incentives to reduce runoff altogether. And this stormwater utility, it creates an equitable way to fund the stormwater treatment, because the user fees are based on how much runoff is produced. And so it's not based on the property value or tax status or anything like that. It's basically how much impervious surface do you have? And then we charge you the fee based on that. So again, that market incentive kicks in. If you want to reduce your stormwater utility fee, you simply decrease the amount of impervious surfaces that you have. And therefore, we're catching that stormwater before it goes into our system and then out into the river. We're also engaged in a number of educational efforts and related to leaves and mowing and all kinds of things, just as a process to help reduce those phosphorus-rich nutrients from entering the system to begin with. And so we're engaged in quite a bit of that here in the city of La Crosse, as well as, and of course, that's for our stormwater utility, but we're also, in our city, we've engaged in the largest public works project in the history of the city of La Crosse through a wastewater treatment plant upgrade project that not only will help improve the effluent out of the system now, but also help us deal with contaminants that aren't even permitted yet. And so we're forward thinking, and a lot of our member cities up and down the Mississippi are doing the same thing. So the last thing I want to mention is just a word on policy steps at the basin scale. And as that we're doing that collectively as mayors. The Safeguarding the Mississippi River Together, or SMRT Act, it's an innovative approach that improves the federal coordination. It restores natural infrastructure, supports new approaches to remove nutrients, and protects a thriving and sustainable economy on the Mississippi. SMRT establishes a national Mississippi River Program Office. It authorizes transformative new grants to help our cities embrace a greener economy and assist states with errant nutrient reduction. Further, the act establishes the method by which a comprehensive Mississippi River management plan can be devised. Now, as communities on the Mississippi that are most vulnerable to flooding, we have to take substantive efforts that will not only protect communities like La Crosse, because we've seen increases in the amount of flooding that we over the last many years, but also to improve the water quality and climate policy to ensure that, of course, the next generation will be in a better position than we are today. All right, so that's what I have, and I have to remember, remind me, I don't remember who I'm actually handing this off to, so I'll just give it back to you, Dr. Fleming.
Great, thank you so much, Mayor Reynolds. That was really, really wonderful remarks, and I think really helpful for all of us to be reminded of the scale of these issues and how these local levels really connect to whole country. And I think if we think back to Dr. Tank's slide with the map of the Mississippi drainage, and then all the way down to the Gulf, and your explanation of how many people depend on these resources. It really reminds us that this scale is immense and there's so many issues, multifaceted, that really feed into maintaining good water quality, drinking water, ecology, and also equitable conditions for just towns and cities throughout this region. So we have a few questions coming in on the chat, but we also really are excited to connect each of you, the panelists, to each other. And when we arranged this panel, unbeknownst to us, it actually turns out that many of you already know each other and have worked together before. Part of our vision for today was trying to have all of us, panelists and audience members, understand more and see behind the curtain, if you will, of how we translate information and knowledge and data to action and policy. And so since it turns out that some of you have already been working on that together, we thought we'd open the floor to all of you to take a minute to perhaps explain to us how some of those connections have already existed between you. What type of work have you done together? Who are the end users of that work? And just tell us a bit more about those partnerships and that flow of information. Yes, Dr. Tank, start us off. Thank you.
Yeah, I might start. I just sort of riffing off the term partnership. I just want to emphasize that, you know, when I did my dissertation research when I was in grad school, I was at the U.S. Forest Service. I was behind gates, you know, everything was protected. Then I started a faculty job and realized, oh, it's the real world. You can't just waltz onto, you know, these are working lands that we're dealing with. And in order to quantify, say, for example, the benefits of certain types of conservation on working lands, it's all about partnerships. And for us in the work that I've been doing in Indiana, it's been the soil and water conservation districts in each of the counties where we've been working that have been really, and I say gatekeeper not in the most positive way. They've been the facilitators of the relationships between the private lands and the, you know, implementation of conservation that may be incentivized by the federal government, and scientists that want to get on the ground and measure those impacts. And it's not, I mean, I think when I hear Mayor Reynolds talking about the Mississippi River Basin and the coordination among all those mayors, I mean, it's an amazing coordination. I just wonder, how do we, when we're talking about on the ground implementation, how do we catapult those partnerships to that scale? I just know that even at a small watershed scale, the coordination is intense and the partnerships must be strong. So yeah, it's an ongoing challenge, but also super exciting to see that coordination at scale. So I just wanted to reemphasize the importance of partnerships.
Yeah, great. Yeah, go ahead, Claudia. You wanted to say?
Jen, if I could just, continue off of that and maybe, ask a question of Mayor Reynolds as well. It seems like the relationship between practices and farming in the communities that are outside of the cities has big impacts downstream, on the communities in the cities. And I'm just kind of curious what those conversations are like, what those relationships are like, because impervious surface is not really the issue in rural areas. That's kind of more of a city question. So I'm just wondering what those, how you bring those communities into the conversation so that it's, it is broader than just cities or the farming communities.
And I think that you were asking that question of me. So I just want to, let me just weigh in, is that I think the key to remember is that we can't do it all at once, and the mayors, we can have our community get together and try to influence policy to the extent that we can among our urban centers, and then try to broaden that out throughout the entire basin. But this is a massive area, and and our organization can influence policy, and it certainly has, and we're able to make some headway in that regard. But it does require that coordination, those relationships, as Dr. Tank was talking about. This is a relative, our organization, MRCTI, is a relatively new organization, and it's had a significant impact on policy at the federal level, which is impacting our entire basin. And so it really has to happen at that level. And that's why we're together to begin with, is because, like I mentioned, that's because we're getting our drinking water, from the Mississippi. That's primarily it. But also our livelihood depends on the maintenance of this resource, as not only a drinking water source, but also as a transportation source, and then a recreation avenue as well. And so, it's my hat's off to my predecessor, which was one of the first. He was one of the first members of this organization, MRCTI, and I think that it will require more of that cohesive organizational structure for other groups to have as much of an impact.
Yeah, just continuing on the theme of partnerships, one of the newer things that's been going on in Wisconsin is the Department of Ag is sponsoring what are known as producer-led watershed groups. So these are grants that are provided by the state to these local groups that are composed of farmers, essentially, who are self-organized, write a proposal for what they want to do. There's a lot of freedom for how to structure that. And then that provides, once they're organized, that allows those groups to share information with each other, but it also kind of provides a contact point in a public face for a group that's within a watershed typically. So I think it helps facilitate those communication lines between like the more urban community and the rural community, when these these farmers who sometimes wouldn't necessarily talk to a community group, for example, are part of a group, and so they might have a spokesperson who can assist with that communication. And it's really growing quickly in Wisconsin. I'm sure there's other states who are doing something similar. But yeah, I just wanted to bring that up as a really promising avenue.
Yeah, thank you, Matt. That's a great point. It seems like such an immense effort to coordinate, even just at local levels, across different users and communities. And then when we think of the scale of the whole Mississippi River and the work that the mayors are doing, it's really, kind of astounding and perhaps overwhelming at times, but I think so important to remember that communication piece. And we had, on this topic of partnerships, we've had a few questions come in on the chat regarding, are there any existing efforts for partnerships and or better communication with indigenous groups, or building upon practices, agriculture practices, land management, water management practices, or knowledge that come from indigenous groups locally into either MRCTI efforts or any of your work that's more local? We'll pitch that to any of you who want to join in on that element.
I'm not able to address from an MRCTI standpoint because I'm not aware of any initiatives that we have as an organization. Locally, we are in, again, we as an urban place, we don't engage necessarily in farming practices a whole lot, but we have, that's definitely something that is part of an educational effort that is ongoing in areas surrounding us. I would like to think that we could probably do a better job of doing some engagement like that, but there's always room to improve.
Mm-hmm. And so that's engagement regarding agricultural practices with indigenous communities. Correct.
Yeah, I think that it's, and again, I would have to do some looking since that question was posed in relation to MRCTI. I guess I don't have an answer for whether that exists as an initiative from a higher level organizational level. I have to admit I'm a little ignorant of that. But I think that that's certainly something that we can make progress on locally.
That's great. That's great. And Dr. Tang, did you want to add to that?
Yeah, I just wanted to mention that I think there's an interesting, at least my experience is in the St. Joseph River Basin, which is at the boundary of Michigan and Indiana, but a lot of it's in Michigan. And the Pokagon Band of the Potawatomi are part of the watershed, and they have been very innovative in how they want to manage what's interesting is manage both tribal lands as well as influence others to make choices that are consistent with how they want to manage. And they sort of take the best out of the science and the management that's happening in the rest of the basin, and then just sort of move forward. So they've been quite, I would say, leaders, in particular on the Dowagiac River, around restoration of floodplains and meandering informally channelized parts of the basin. And so I think it's an exciting leadership role. What we're trying to do, we've been trying to sort of match make a little bit with City of South Bend, and as well as the broader watershed, getting everyone talking at the same table. Again, I think that's where the partnerships could really create a synergy. But I think that they are playing a real leader, at least in the St. Joseph River Basin.
Great, thank you for that. Yeah, Claudio.
Yeah, just inspired by Jen and Mayor Reynolds' comments, I think it's worth remembering that our landscape here in the Upper Midwest, and it didn't look like it looks like today. 150 years ago, we're practicing a form of agriculture right now that is continuously tilling up the soil, putting in a lot of agricultural inputs. And that's the leaky nature of this system. So, in addition to the really, neat things and innovative things that we can do in working within this system, there's also alternative types of farming systems, perennial-based, pasture-based, agroforestry-based systems whose entire design is to actually always keep the soil covered, so that there isn't leakiness at all times of the season, not just not just like what can we do on the shorter ends of the season. So I think there's actually a lot of inspiration to be drawn from indigenous practices, from rotationally grazing, from moving animals in the landscape, reintegration of animals in the landscape, which are incredibly powerful in keeping soils together, healthy, high organic matter, really productive, and it's also a viable farming opportunity as well. So I think just even re-envisioning like what is possible in the landscape is something that we should be pushing ourselves to do.
And listening broadly in order to do that, right? If that re-envisioning is bringing different perspectives to the table and hearing new ideas that are maybe not new actually at all, maybe very old ideas and traditional ideas that we're often leaving out of the conversation. Yeah, great. Thank you all for that. I think we have a few more questions from the chat that we'd like to share with you.
Yeah, we got a bunch of great questions coming in. This one, I think is going to be directed to Matt, would be my suspicion. But it's from Kermit Hobie. What about the impact of groundwater infiltration of phosphorus? What risk is attached to phosphorus, even if it doesn't drain to surface water bodies?
Yeah, that's a good question. And some phosphorus is generally pretty sticky to soil. There's some dissolved phosphorus that can move into groundwater. It's not as much of a concern for groundwater quality for drinking water, for example, as nitrate is. But it can move through tile drains, for example, in a dissolved form. And so some of these depressional areas that I was describing have been tile drained. And so we can't see that on this terrain surface itself, but there's that underground movement pathway. So in this area, most of the phosphorus still moves in surface runoff, so that it's a smaller piece of the pie, essentially, that's moving through the ground. It's not that it's completely unimportant, it's just not the major issue. Because really, what kind of the point in this whole analysis that we're doing is trying to prioritize where we're working. We know that we can't do everything everywhere, so we want to get the most bang for the buck where we're working.
Yeah, fantastic. Thanks for that. And we have a couple questions that I'm going to try and sort of combine together a little bit because I think they actually connect to some of the points, that maybe we're just making around, thinking about these broad connections and maybe really thinking about a bit of a broader revisioning of food production and how it links to water quality. And so in particular, we've got questions around maybe Claudia sort of following up on these ongoing efforts and really thinking about sort of regenerative ag, both what is sort of currently happening, whether in the form of encouraging cover cropping, other ag practices, and for example, can we envision a world where maybe in the next farm bill, we actually have more support for regenerative ag? So maybe sort of to Claudia or to other folks, what are the ongoing efforts and what can we sort of envision as the near future potential for alternative agricultural practices and what that might mean for health of water quality?
Yeah, and I'll just kind of continue maybe on a few of the points that I was making before, having to do, the idea of the regenerative is that, we're actually creating an agriculture that is actually building instead of extracting. We're building soils and building habitat, and we're building an environment where there is kind of a positive trajectory, particularly with soil health, but with a lot of other things. And those typically are systems that actually maintain roots in the ground all the time. Perennial pasture-based systems is one of the cases. It's good at keeping soil together, so we're actually building soil, but it's also really good at keeping nitrogen, at building, habitat for birds and bees. That's the stuff I get excited about. And a diversified system that actually maintains animals as well. So those are things that are starting to get going, and you'll see them a lot in the popular press right now. It has all kinds of various terms: regenerative ag, I guess the question is, what are the actual outcomes that agriculture is trying to actually, obtain? So so I think I'm just going to leave it at that. Really, the idea of like cover crops and other things that work within the system, those are going to be great solutions for some parts of the landscape. They're just not going to be ideal in a lot of parts, especially as you get up further north here into Wisconsin and beyond. The ability to get cover crops in there is actually really limited, when you can get in there, and therefore how much green can you actually get in October and November and into the spring as well. So there's going to be some regionally appropriate solutions to the kinds of agricultural systems, but the idea of having perenniality out there longer, I think, is one of those things that might have broad impacts around. Maybe I'll hand it off to Jen to say more about opportunities there.
Yeah, I was just going to follow up. The thing is, I think we do need some sort of huge sea change, really, in the way we look at the sort of our agricultural landscapes. And I've often tried to, find an analogy that works. Someone can send me one if they think of one, but it's like, roofers don't tear off the shingles and start roofing in December around here. They just don't, they know not to do it. Construction folks, they put up, they're not even allowed to clear the land during certain times of the year unless they put up precautionary fences. I mean, we have norms, right, around bare ground, but we don't seem to have it for agriculture, and so I feel like if there were sort of a shift in the norms, like you want to protect that with a blanket, pick your blanket, but you never leave it bare, type of thing, would go a long way, even in the most traditional systems, because there's a lot of the Midwestern corn belt that's going to probably stay in corn and soybeans for the next wee while. And so how do we, I think, in order to make an impact in something as large as the Mississippi River Basin, and so we can stop getting the reports from, folks standing in the Gulf of Mexico saying, hey, Midwest, you're doing nothing up there, because people are trying. It's just a very large area to change. So I think, low-hanging fruit is something like changing norms about bare ground, and then how you do it is maybe site-specific. And there are incentives. The federal government will pay out for this under programs like EQIP. The thing is, they're just paying out to try it. So it's a couple of years. And we know that large-scale change, people aren't going to flip the switch in a couple of years. They need to change soil organic matter on a measurable scale. You need 10 years of cover cropping. Well, if that's the case, we got to find other incentives, other ways to offset the change that farmers are making when they're usually done in late fall. And now you're asking them do something else and think about it for the next 7 months. Adds complication, adds complexity. So we've got to figure out, I think it's probably private market solutions that are, pricing of commodities based on the type of conservation you use, what steps, getting credit for the steps you're taking. So anyway, that's a long answer, sorry, but
No,
I
that's
think,
very helpful.
we're moving in the right direction, and we gotta jump start it, I think.
Yeah, thank you. Those are great points and really helpful to sort of understanding what change is needed. Regarding making that change, we have just a few more minutes before we close, but regarding making changes, I'd love to hear more from Matt and Mayor Reynolds about some of either the specific goals, for example, of the MRCTI in the next 5 to 10 years to make some of that change. And or Matt, you would reference the goal of moving towards zero with the sort of net level. And if you could take a moment to talk about how we get there and if we could get there. So maybe first Mayor Reynolds and then come back to you, Matt.
Okay, yeah, thanks. Yeah, I think that overall our longer term goals is, we look at water retention. There's a couple different objectives, obviously, as Mississippi River mayors, and one of them is flood hazard mitigation. And so we see these two things coinciding, the flood hazard mitigation processes as well as the clean water processes. And that is partly why we're developing natural assets up and down the river for water retention, essentially, so that we don't have these tragic flooding events up and down a river, or we can mitigate them to a certain extent. But also there's a water retention process there as well. And I think that's really, when we look at the longer range, higher impact types of things that we can do, it's to do those very things, is to have that water retention in those wetland areas. It's interesting when you look at the forgive me, although I was introduced as an expert, I'm not actually a water expert. So I think you, Dr. Tank, I think you said hypoxic. Am I using the right word? Okay, thanks. I actually, believe it or not, I lived for a long period of time in New Orleans, and my family actually had a crab boat, and so we're very aware of the lack of. We were very aware of the lack of oxygen. When you get out to a certain point, you're like, oh wow, there's nothing living here. But that's the kind of thing that we're looking at, is that the retention of those, obviously those massive amounts of nutrients that just flow out there and create that massive dead zone, which is what we call it, by the way, the dead zone. And in doing so, will also help us mitigate the flood hazard. So it's a multifaceted approach, really. And then overall, just like we're doing in the city of La Crosse, limiting or making sure that we're improving the effluent from our wastewater treatment plant. That's a huge deal. And I think that everybody recognizes, we haven't even talked about the PFAS chemicals yet, but everybody recognizes how significant that is, and what we need to do as a community and and generally as a society to improve our water treatment processes, are not only sanitary but stormwater, so that our effluent is something that is not making things worse, frankly.
Great, thank you. And Matt, I know we're tight on time, but Matt, if you want to close us out.
Yeah, just one kind of small or kind of narrow perspective on this. How do you get to the goal of balancing the phosphorus mass balance? And one approach that's being talked about is, instead of bringing in all this synthetic fertilizer phosphorus, we have a lot of manure production in the watershed. Some of it is going to digesters, and the digested products, the solids, are being exported and used for fertilizer elsewhere. Some of it could actually be used, redistributed within the watershed and replace the synthetic fertilizer. There's challenges there with just transporting the material around and the cost of that. But with the increasing costs of fertilizer in recent years, buying fertilizer, there's more incentive for farmers to figure out ways to reuse the nutrients that they have on hand, essentially. So I think that general tactic is, I think, going to probably play the biggest role in getting towards that net balance that we're looking for.
That's great. Thank you so much, Matt. That's really helpful. Sort of closing thoughts there on retention and reduction. Very helpful words for us to keep in mind today.
Yeah, absolutely. And I think with that, I believe we're at time. So I'll just say a huge thank you again to all of our panelists. This was a really fun conversation and obviously very complicated, but critically important issues. And it's really, fun to just get the multiplicity of perspectives here and approaches. And some great visions for, I think, moving forward. So thanks again to the panelists, and also thanks to all of the audience for all the wonderful questions. I'm sorry we didn't get to all of them, but clearly plenty of interest. Yeah, and follow up, I'm sure, feel free to reach out to us or panelists with any follow-up questions, and we can continue the discussion.
And hope this created some conversations amongst the panelists today as well. We really appreciate you thinking across.
Thank you, everyone.
lines. Yeah, thank you so much, Mayor Reynolds. Great to have
Thanks so
you.
much.
All of you, thank you.
Bye now.
Thank
Bye,
you all.
everyone.
Happy
And
Earth Day.
Happy Earth Day.
Earth Day.